What is going on, everybody? Welcome back to a brand new video. So today we're going to be going in another LeetCode problem, and we're going to be looking at palindrome problems today. So we're going to go through two pretty easy palindrome problems to just get our feet wet and get kind of comfortable with these things, as they are common interview questions. If you guys have been enjoying this series and want more LeetCoding problems, don't forget to subscribe for more future daily videos. So today our problem is given a string, determine if it's a palindrome, considering only alphanumerical characters and ignoring cases. So this is going to be pretty easy. All we have to do is remove all the alphanumerical characters, remove all the spaces, and then check if it is a palindrome. So we're going to take advantage of a few STD algorithms today. STD transform using our iterators. So we're going to just iterate over the entire string real quick using a transform, and then we're going to just put in a quick little lambda function here, char c, and we want to return something like is alpha or alnum, right, alphanumeric c, and we can use a ternary if here to make this super clean, something like that. So what we're going to basically be doing here is transforming this function and replacing all non-alphanumerical characters with spaces. So let's just quickly print that out, make sure it works real quick, and let's just return true because we need to return something for this to work, and run our code. So we should have removed the commas and the colon, and we do, and we replace them with spaces. So that's working exactly as we would expect, right? We're using a transform function. Next thing we want to do is we can declare a string of type iterator. We'll call this remove position, and we're going to remove all the spaces using another algorithm, std remove, s.begin, s.end, and double quotes, right? And then since basically, so what's going to happen is this is going to remove all the spaces, but it's not going to delete our necessary characters. So if I were to still print out s, you'll see that it doesn't work as we would like to see, right? We get, oh, no name type. Oh, that's because I have an N in there. Sorry about that. But let's just show you guys. So this isn't actually going to remove all the spaces. It's just going to move them. So you see we still have all this leftover stuff. Basically what happens is it removes them, but we don't update the position of s.end iterator. So to update that position, we can just do s.erase remove underscore position s.end, and what that's going to do is it's now going to set the remove position iterator, so this position here, to be our new s.end, and now we should see that this spaces and Panama is now deleted. Let's go through that, make sure that works, and we do see that it is deleted. So now we just have a string with no spaces, no alphanumerical, or all alphanumeric characters. How do we check if it is a palindrome? Well, what we can do is we can set two variables. Let's just call them I equals 0, and we can set a variable j equals s.length minus 1. So what we're going to do is we're basically going to iterate inward. So we're going to check if this a matches this a. We're going to check if this m matches this m, this a matches this a, and so on and so on. So we do while I is less than j, right? Because once they cross, right, we don't need to iterate anymore. We can only iterate through half of it. We'll do I minus minus, or let's just do minus equals 1, j minus equals 1 so that we're clear. And we do if s at I does not equal s at j, return false, something like that. Otherwise, return true if we get through this whole thing. So let's just run that code. It should work there, and let's see what happens. Oh, we get an error actually. Output is false when we expected true for some reason. Let's just check what is si and sj that is causing us to return false, because this should not be happening, right? This is a valid palindrome as shown in our example, and we see, oh, we have a case issue. So we need to use the toLower function. So if we do something like toLower, something like that, s at I, and toLower s at j, something like that, that should be our valid palindrome. Let's see if that works right there. And there we go. So it was the toLower issue. we can just clean that up by making them 2 lower. So basically, this will check if we have a valid palindrome, right? We're going to count inwards from the left and right sides until the values cross. When they cross, we know we are good to go, and we have successfully reached a valid palindrome. If at any time we find the values are different, we are going to say this palindrome was unsuccessful. Hopefully this works. Let's check it out here in our submissions. Oh, we get a weird error. Race a car is actually wrong. Interesting. So let's test this case out and see what's going on here. Let's just run that code real quick and basically see what is occurring. So race a car, RAC, space. Output is true, and we should be expecting false. So let's actually just print cout s at I and s at j each comparison, and std and l. So let's just run through that and see where we should be having a issue. RR. So for some reason, our values are not iterating properly. Oh, that's because I should be plus. Plus equals 1, minus equals 1. That's weird. There we go. We should get the correct value in this case. It is false. There we go. It's just a small little mistake there, and let's rerun it and see if we are good to go. For some reason, we have the null string fails. So we have, let's see. Let's run this again and see why this is actually failing. I is 0, s dot length minus 1. Oh, that actually can't be a uint because that is going to be -1, right? So if we change those to integers, then we should be good to go. And we successfully did it. So basically what happened there is if null string, right, the length is 0, 0 minus 1 is -1. We can't have an unsigned integer be the value -1. All right, everyone. So now let's hop over to the second problem we have here. This one's just a continuation of the first one. Basically, given a non-empty string, we can delete one character, and we need to judge now if it is still a valid palindrome. So we could have ABA, which is true, ABCA, which is still true, but because we could delete the character C. So this is a little bit trickier. Basically, what we need to do is we need to check, basically, we can do, my general thought process is let's check if ABA is a palindrome, and if ABA fails to be a palindrome, let's check if we remove one of the characters at where it fails, if it is still a palindrome. So first thing let's do is let's just copy and paste our function here, and we will just use this. It doesn't say it has to be alphanumeric. So, it already tells us the strings will contain lowercase characters A to Z. So we can just copy our previous one, and we can do bool is valid, and we can take in a string s. Just that way we don't have to rewrite this function, and we actually don't need the 2 lower here because it tells us it's going to be lowercase anyway. So that's just to check if we have a valid palindrome. So basically what we can then return, we can do is we can see, we actually don't need to write a new function header. I apologize, everyone. We can then, if we fail, we can then return basically we can then check if each one is a palindrome or not. So we can return, let's actually make a function here. Is valid no remove, let's call it that. String s, right? And what we're going to do is we're actually going to paste this again real quick to check if it is a valid palindrome. And what we can do is we can basically just call this function. We can basically call this function here with an OR statement. So what we're doing is we're checking if it's a palindrome here, right? And we're saying if they aren't equal, we can return is valid no remove s where well, let's do s, I, and j, right? So that way we can keep our position so we're faster. and let's go integer I, integer j, something like that. And we can do s I minus 1, or I plus 1, j, something like that, right? To skip the first character in the s value. So that checks if, say, we have b, we will skip over b in this case, so it's ACA. And we can do the same is valid, no remove, s I j minus 1 with the same kind of logic, right? And if we run that code, we should see it works for a, is valid, no remove, error, C++ requires type. Cool. Also, I probably will have to move this above here so that it sees it. Oh, no, we good to go. So this works for a simple case ABA. Let's check ABCA, this case here. It should still return true because is valid, no remove should return true. And see, we quickly can solve this double palindrome problem without much difficulty, right? Oh, wow, we were pretty slow here, 6.08 seconds. That's not too great. But generally, we're not really going for speed right now. We're just trying to get a accurate and correct solution. So this is sort of how we would do it naturally, right? With is valid, remove I, and is valid, remove j. Basically, what we're doing is declaring a palindrome here. We're iterating through, and if we find that they mix, we return this function. So hopefully that was helpful and a little bit of an introduction on how to kind of write palindromes. We also, touched a little bit on our STD algorithms, which I hope you guys have been following and sort of brushing up on. If you guys enjoyed this video, don't forget to leave a like. And if anything was confusing whatsoever, feel free to leave me feedback in the comments. Till then, I hope you guys all have a fantastic day and see you.